Okay, let's begin. Now know that whenever you want to solve definite integral questions with Casio calculator, the calculator should always be in reduce mode to avoid unnecessary error. Very, very important. So take note of these points. Having known that, let's look at the examples I have here and solve them together. Example 1 here says, evaluate the integral 7ds over x squared minus 5x minus 6. So right now, let's bring the Casio calculator and solve this question together. Okay, the first thing you have to do will be to put the calculator in reduce mode. As you can see, the calculator is in degree. To change it from degree to reduce mode, you simply press Shift, this mode button after pressing Shift, and go for category 4. This stands for reduce, so it's now in reduce mode. The next thing you have to do will be to input these integral values in the calculator. Don't be confused with this ds here. It represents or stands for function. What this means is, if you are asked to read this question, instead of saying evaluate the integral 7 over x squared minus 5x minus 6, you say evaluate the integral function 7 over x squared minus 5x minus 6. So you will need to include function while reading out the question. So that's what this ds is standing for in this question. It stands for function. So don't be confused with it. So having known that, let's input these values in the Casio calculator. To start with, you bring out the integral symbol, then move your cursor up and input the upper limit value there. So upper limit value there is 10. You come down, lower limit value is 7. You move your cursor to this empty box and input the values there. So it's in function have 7 over x squared. So to bring out x in the calculator, you have to press alpha first and x. If you just press x alone without pressing alpha, x will not come out. You will have to press alpha first before pressing x. Very, very important. So take note of this. So here we have x squared minus 5x alpha x minus 6. So that's it. This is exactly what we have here as the question. So let's press report and see what we get as an answer. We have 1.0678. So let's check the options. The options are not in decimal places as we have here. So we have to evaluate each and every one of the options we have here to put them in decimal places in order to know the right option. So right now, let's start with option A. So it says length 32 over 11. So look at length button. So it is in fraction. We have 32 over 11. We close the brackets. 1.0678. Okay, so this option A is the answer. No need evaluating option B and C, since Option A gives us the exact value we got when we did the integration for this question. So option A, the answer is as easy as that. Just put the calculator in reduced mode first and input the values, the integral values, and subtract. You get the answer. Let's solve one more example. This example 2. So example 2, I say evaluate the integral function sine 3x plus 2x. So to start with, let's bring out the integral symbol and input the upper and lower limits. Upper limits there is in fraction pi over 2. So to bring out pi, you press shift. Pi is here, this button, over 2. You come down to the lower limit. The lower limit is 0. So you move your cursor to this empty box and input the values here. There we have sine 3x alpha x equals the brackets cos 2x alpha x equals the brackets. So that's it. This is exactly what we have here as the question. So let's press record and see what we get as an answer. 3/5. So the right option here is option B. 3/5. Very, very simple. It's as easy as that. So guys, this is basically how you can use Casio calculator to solve indefinite integration. Very, very simple. Make sure that the calculator is in reduced mode before you begin to solve anything. Very, very important. Okay, let's begin. Now note that whenever you want to solve indefinite integral questions, the calculator should always be in reduced mode to avoid unnecessary error. Very, very important. So take note of this point. Having known that, let's look at the examples I have here and solve them together. Example 1 here says compute the integral function s cubed exponential raised to the power s. So right now we are going to evaluate this integral function s cubed exponential raised to the power s with the Casio calculator. So let's bring the Casio calculator. Okay, the first thing we will have to do will be to clear the calculator. The essence of clearing the calculator is to avoid unnecessary error, because you might not remember whether you have performed a previous calculation on the calculator. So to clear your doubts and to be on the safe side, you are advised to clear the calculator. And to clear the calculator, you simply press shift button 9, you put the instruction, want to clear all, press 3, you press equal to and equal to again. So we have cleared the calculator. The next thing we will do will be to put the calculator in reduced mode. As you can see, it's in degree. So you change it to reduce. To do that, you press shift mode button. Category 4 stands for reduce. You press 4. So the calculator is now in reduce mode. So the next thing we will do now will be to store a real number in the calculator, like 2, 3, or 4. We will use to evaluate this integral function we have here. But we are going to work with 2 in this video. I will also recommend you to also work with 2, because I have practiced with 2 personally for a long time and I have not found error with it. So I will recommend you to be working with 2. Having known that, so let's start 2 in this calculator. To do that, you simply press the number 2 then press shift, then store this RCL button, then press the alphabet X. So once you do it, this will indicate that 2 has been stored as X in the calculator. So you wipe it and input the integral function. So there we have x cubed. To bring out x, you press alpha first before pressing x. If you just press x alone, it will not come out unless you press alpha before pressing x. So take note of this. We have x cubed there. So you use this power function and press 3. You come down, exponential raised to the power x. So you press shift, exponential is here, raised to the power x, alpha x, press equal to 59.11. Okay, so right now we are going to differentiate each and every one of these options to break these polynomials down. We are going to differentiate each and every one of them to put them in whole number. So any of the options that will give us 59.11, as we differentiate them, will be the answer to this question. So let's begin. So to start with, you press shift, this integral sign button, to bring out d over dx. So you begin to input the values there. So you have exponential raised to the power x, shift exponential. So we have alpha x. You come down, in brackets we have x cubed alpha x, this power function. You come down, minus 3x alpha x raised to power 2 plus 6x alpha x minus 6. Okay, you don't have to include this plus c. The plus c there is just a constant, so you don't have to include it in the calculator. So you close the bracket to balance the brackets. Very, very important. Make sure you balance the bracket. As you can see at the left hand side, we have 2 brackets, 1, 2. While at the right hand side, we have 2 brackets, 1, 2. So make sure that you balance the brackets. Very, very important to avoid error after inputting your values. So we come here and put the 2 we stored in the calculator. Had even we stored 3. When we come here, we put 3. But since we stored 2, 2 will be put there. So we press equal to 59.11. So option A is the answer to this question. No need differentiating option B, C. So this is how you can solve indefinite integration with Casio calculator. It's as simple as that. In summary, all you will have to do will be to evaluate the integral function and differentiate the options to get your answer. It's as simple as that. So let's solve one more example. The example 2 here says that means the integral function s squared exponential raised to the power x. So let's evaluate the integral function. We have s squared there, alpha x squared exponential raised to the power x. Shift is exponential alpha x. So let's press equal to 29.55. So let's differentiate the options to get the one that give us 29.55. So let's begin with option A. So right now, press shift, this integral sign bottle to bring out d over dx. So let's begin to impute the values. We have x squared alpha x exponential raised to the power x alpha x. You come down minus 2x alpha x exponential raised to the power x alpha x. You come down, you have plus 2 exponential raised to the power x alpha x. Okay, so this is what we have here. Let's confirm, let's check if we are correct. Okay, we are correct. So let's come here and put the 2 restored. Make sure the brackets are balanced. We have one bracket at the left hand side. We also have one bracket at the right hand, so the brackets are balanced. So let's press report and get our answer. 29.55. So option A is the right answer to this question. No need differentiating option B and option D. So that's it, guys. It's as simple as that. This is basically how you can solve indefinite integration in Casio calculator. It's as simple as that. Just make sure that you put your calculator in reduce mode. You store a real number like 2 you use to evaluate the integral function, and also use to differentiate the options and all that, and you will definitely get the right answer. Okay, let's begin. Now note that the method of solving definite integral is used to solve questions involving application of integration, where the higher value of x is the upper limit and the lower value of x the lower limit. Very important. So take note of this point. Having known that, let's look at the example I have here and solve it together. Example 1 here says, find the area bound by the curve y equals 2 square root of x. The x-axis and the ordinates at x equals 0 and x equals 3. So right now, let's bring the calculator, the Casio calculator, and solve this problem together. Okay, the first thing we do will be to clear the calculator. Very important to avoid unnecessary error. We are advised to clear the calculator whenever you want to solve a new question to avoid unnecessary error. So to clear the calculator, you simply press Shift button 9. You follow the instruction 3. You want to clear all equal to again. So we have cleared the calculator. The next thing we do will be to put the calculator in reduce mode. As you can see, is in degree. So to change it to reduce mode, you press Shift this mode button and go for category 4, which is reduce. So it's now in reduce mode. Very important to avoid unnecessary error. Having done that, the next thing we do will be to bring out the definite integral sign in the calculator, because it's through the process of solving definite integral with Casio calculator that we use to solve this application of integration according to what we noted here. So you bring out the integral sign, then impute the upper limit value, which is 3. Then you come down and impute the lower limit value, which is 0. That's this 0. After it, you move your cursor to this empty box and impute this value of y there. So we have 2 roots x. To bring out x, we press alpha x. You have to press alpha first before pressing x. If you just press x alone without pressing alpha, it will not come out. So you will have to press alpha first before pressing x. Very, very important. So take note of this. So having done the necessary things, let's press equal to and see what we get as an answer. Okay, we're waiting for our answer. Okay, we have 6.928. Okay, option A is not the answer, not option B. Option C, we have 4 roots 3. So let's break this value we have here down and see if it will give us 6.928. So let's do it. We have there 4 root 3. So you change it to a decimal number. To do that, you press SD. So we have 6.928. So option C is correct because this is exactly what we got when we did the definite integration for this question. So option C is the answer to this question. It's as simple as that. So this is basically how you can solve application of integration using Casio calculator. Very, very simple. So we have come to the end of this class. If you are new to our channel, make sure you subscribe to our channel for more of our videos. Also like, share and comment on this video to tell me what you have learned in this video or how you feel about this video. That's it for this class. Thanks for watching this video.